So in this first example, we are going to solve the following quadratics by factoring. And you have to remember, when factoring, your quadratic has to equal 0. And I find it easiest to make sure you keep your x squared positive. So I'm going to leave that 3x squared there. Even though it would be less work to move it over, it's going to make the problem more difficult. So you want to move everything else over to be with the x squared. So I'm going to move the 2x over first by doing the opposite. So I'm going to add the 2x over to that side. So I get 3x squared plus 2x equals 16. They are not like terms, so we can't combine them. So I just put that 2x at the end. And then I'm going to do the same thing, but I'm going to move the 16 over to the other side. There's nothing to combine with the 16. It's not a like term. I'm just going to stick it on at the end. So then when I solve this by factoring, I have to pay attention to how many terms there are. And I see that there's 3 terms, so that means I'm going to use split the middle. Always check and see, can I take out a GCF? In this situation, the answer is no, you can't. There's nothing that can go into 3, 2, and 16. Not all the terms have an x, so we can just dive on into splitting the middle. When we split the middle, remember you have to multiply your first and last. So I'm going to multiply 3 and negative 16 together to get negative 48. Then I'm going to write down all the factors of 48, which are 1 and 48, 2 and 24, 3 and 16, 4 and 12. 5 doesn't go into 48, but 6 and 8 do. There are no other factors of 48. So I have to look at my list of factors and figure out which one of those sets is going to combine to give me my middle number 2. And those two numbers are 6 and 8. But they have to combine to give me a positive 2. So that means 6 has to be negative and 8 has to be positive. Negative 6 times 8 gives me a negative 48. Negative 6 plus 8 gives me a positive 2. So that's going to be my middle. So I'm going to rewrite it as 3x squared. I like to put my negative number first. So I'm going to put minus 6x plus 8x minus 16 equals 0. Now that we have 4 terms, we're going to factor by grouping. So we're going to group our first 2 together, group our back 2 together. And when we group, we factor out the GCF for each group. So if I look at my first group, the GCF between 3x squared and 6x. Well, between the numbers, I can take out a 3. And between my variables, I can take out an x. So my GCF for the first group is 3x. So then we write our leftovers. Okay. I like to think 3 divided by 3 is 1. I had 2 x's. I divided 1 x out, so there's 1 left, minus. 6 divided by 3 is 2. And those x's cancel out, so there's no x's left. Bring down that middle sign, which is a plus sign. Between 8 and 16, my GCF is 8. And then I know when I split the middle, my parentheses have to match. So if my first parenthesis is x minus 2, my second parenthesis has to be x minus 2. But to check, just divide everything by your GCF, divide everything by 8, and we get x minus 2. So then, write your parentheses. Your repeating parenthesis, you write 1 time in one parenthesis. Your GCFs go together in another. And we are done factoring. The directions did say to solve, so we have to keep going. When the directions say to solve, you're then going to take each parenthesis and set it equal to 0. And then solve that parenthesis. So to solve here, we're getting x by itself, so we're just going to add 2 to both sides. So x is equal to 2. Here, we're going to subtract 8 on both sides. To get 3x equals negative 8, then divide by 3. And the directions say to leave it as in simplest fraction form. So we have to leave it as negative 8 over 3. Negative 8 over 3 doesn't simplify, but do not write it as a decimal, because then you won't be following directions. Leave it as a fraction. And there we go, solve by factoring. So it's pretty much split the middle, but you have an extra step since we're solving. Set your parentheses equal to 0 using that 0 product law and solve for each parenthesis. And the next example, in example B, again, always check and see, can I take out a GCF? And yes, we can. The number that can go into 50 and 2 is 2. So to write our leftovers, we're just dividing everything by 2. We get 25x squared minus 1 when we write our leftovers. And then once you take out a GCF, look at what's inside your parentheses. I have 2 terms. So there's multiple ways that we can factor. We have 2 terms. But I'm going to look and see, do I have a perfect square minus a perfect square in my parentheses? And the answer is yes. I have 25 minus 1. 25 is a perfect square. 1 is a perfect square. So I'm going to use difference of squares to factor. So I rewrite my GCF. Okay. When I use difference of squares, I always have 2 parentheses. One parenthesis has a plus sign in the middle. The other parenthesis has a minus sign in the middle. And then to fill in your parentheses, you just square root each term. The square root of 25x squared is just 5x. So first term, first spot in each parenthesis. The square root of 1 is 1. And check what I wrote. There's nothing else I can factor. So then I'm going to go ahead, set each factor equal to 0 and solve. 2 does not have an x. So it's pointless, okay? There's nothing to do there to solve. So you're ignoring the 2. We just did that to kind of simplify things so we could factor. But you're not going to do anything with that 2. There's no x, there's nothing to solve for, so you just ignore it, okay? But we can set our parentheses equal to 0. So yeah, x by itself, just move the 1 over. So we get 5x is equal to negative 1. Divide by 5. So x is equal to negative 1/5. There's that answer. You're pretty much doing the same thing here, but instead of subtracting the 1, you're adding it. So we get 5x is equal to positive 1. Divide by 5. X is equal to 1 over 5. Again, directions say to leave your answer as a fraction, so we left it as a simplified fraction. There you go. Now, go ahead and try those 3 problems on your own. And when you get done with those 3 problems, try the quadratic formula on the back.